Okay, so hello everyone. My name is Samantha and I'll be talking about the interaction of daylight and electric light on subjective light appraisals in office environments. So the main goal was that we wanted to look at how lighting can improve human daytime functioning. And the things we can think about here is to improve their alertness, but work performance, and just general well-being. And this project, as Kevin mentioned, is part of a larger project, so the Optilight project, and the main goal is to quantify the human needs in lighting. So we want to go towards a user-centered system, so we have the user in the room, we have the input, in this case the lighting, but also other factors in the environment, and that leads to an output such as, for example, the subjective alertness. And by doing this project, we want to gain insights in how they experience the light, and eventually we want to translate this knowledge into models. So how can we predict how humans will react to a certain light setting? So we did a field study in a real office environment. There was an office in the Netherlands which was so kind enough to let us measure over there. So we've been there in total for 6 weeks. And there we did multiple measurements over the days and over the weeks. So as you can see in those pictures, in the first week we gave them a bright light in the morning. And bright light in this case, we wanted to try and get about 400 lux on the vertical plane. And in the second week in between, they didn't receive any extra bright light. And then in the other week, we gave them extra bright light in the afternoon. And the reason for switching between morning and afternoon is to also be able to look at those time of day differences. And the benefits of doing this field study is, of course, that we could also do longer light exposures. Our group is used to doing studies in the lab where we usually expose people to about 1 hour of bright light. And here we could do it for 4 hours and then for multiple days in the week. And of course, when you do a field study, you also get daylight contributions. So in this office, they had quite a lot of windows. So of course, now we had to take that into account as well. And so after 6 weeks of measuring, this resulted in a rich data set. And for what I'm presenting here, we wanted to focus on the relationship between those subjective light appraisals. I'll talk about those a bit more. And objective light measures using a simple measurement device in a real-life office environment. So this is the data that I'll be talking about. So we have the subjective light appraisals. So the participants used an application on their phone, and about 8 times per day they got a notification that asked them to answer some questions. So we asked them about how pleasant they thought the light was, but also about the brightness of the light and the color temperature. And we also did the measurements of the light in the ceiling. So on the right you can see a picture of the simple measurement device that we used. There were 3 of them located in the office and they were placed on the ceiling. And they measured at a 10-minute interval using high dynamic range images. And for analysis, we calculated 3 different light outcomes. So we have the total luminance, so the combination of the electric light and the daylight. We have the daylight ratio, and then also the contrast. And all of this was measured on the horizontal plane, so on the desk of the participant. And we measured it individually for every office worker, of which there were 10 in the office. And the reason for doing this whole project is, so for perceived brightness, there's already some literature known on how to predict that. So multiple measures have been found to predict well, and no such measures are there for predicting pleasantness. And the reasons for predicting pleasantness is that, well, providing pleasant light conditions in general can be a challenge. And studies have shown that when persons positively rate the light, this can improve their mood, their well-being and satisfaction. We see that often participants prefer daylight. So does that mean that if you get positive light appraisals, this is also a happy office worker? And what we wanted to find out is can we predict the light appraisals? Because what we did now is we measured for 6 weeks. We asked them 8 times per day what they thought of the light. And of course, you can't do that in reality. For the results, so we analyzed the data using linear mixed models. I didn't want to go into detail about that, but feel free to ask questions on it later. So we first tried it with perceived brightness. What we can see is that the luminance measure predicts it well. So if the luminance is higher, then they also perceive the light as brighter. And on the right side, it's the daylight ratio. So a higher ratio in this case means that there's more daylight. And what this graph shows is that when there is more daylight, people perceive the light as dimmer. So we try to do the same thing with pleasantness. And here it didn't seem to work as well. It seems less obviously related. So in the models, we saw that there is indeed a significant main effect of luminance to predicting pleasantness. But when looking at the fit of the model, it seems less obviously related. We've tried to explore a bit if that relationship might not be linear, because that's what we assume now with our analysis. So we tried the same thing with daylight ratio. So what the statistics showed is that a higher daylight ratio is seen as more pleasant, but the model doesn't fit as well as we had hoped. And then we tried it with contrast, but that was just a flatliner and didn't work well as a predictor. So for the conclusions, we did find a main effect of light measures on pleasantness, but the trend seems to be very subtle. It might indicate that there's not a linear relationship, and it seems that people do seem to prefer daylight. So what we wanted to learn by presenting here is other ideas for exploring this data. So what relationships should we look into, and are we using the right light measurements? So that was it. Thank you for your attention.
Thank you very much, Samantha.